Today we're going to continue our discussion on scatter plots and correlations. We're going to talk more specifically about correlations and what they mean, and we're also going to talk about some other characteristics of scatter plots. Now remember, yesterday we talked about correlation. We could have three different possibilities. One was a positive correlation, where both the independent and the dependent variable are increasing. The negative correlation happened when our independent variable was increasing and our dependent variable was decreasing. And then we could have no correlation when the data points didn't seem to have any relationship at all. We're going to define correlation a little bit better today by using what we call a line of best fit. Data that appears to have a linear correlation or tends to make a line when we graph it on a scatter plot has what we call a line of best fit. And what we do is we use the graphing calculator to construct the line of best fit. The graphing calculator also tells us a correlation coefficient. Now, the correlation coefficient tells us how well the data actually fits that line, or how close the data is to the line. Now, the directions for finding the correlation coefficient and the line of best fit I've listed here in the notes. But a lot of times it's easier for me to just show you rather than walk through the steps themselves. So what we're going to do is we're going to work on an example, and we're going to find the line of best fit and the correlation coefficient walking through the example. If you need help when you're working on your homework, the notes are there and the steps are there too to help you as well. So if we take a look at example 1, this is the example that we saw yesterday in the notes. I just copied over the scatter plot that we created. What we're going to do is we're going to find the equation of the line of best fit, and we're going to use the graphing calculator to help us do that. And we're also going to find what we call the correlation coefficient. And again, the correlation coefficient tells us exactly what kind of correlation we have. Now, the first thing that I want you to do is look at those data values, and I want you to actually sketch on the graph what a line that best fits the data would look like. Okay, so I want to create a line that's going to come really close to those data points, and I'm just going to sketch it in there. Now what we want to do is we want to actually find the exact equation of that line. Sometimes it's going to be a nice exact equation, and other times we're going to have to round it because the line won't fit exactly the data points. So in order to find the equation of the line of best fit in our calculators, we're going to open up the calculator and we're going to hit the stat button. Now what we need to do is enter the data from the table into the calculator. So I'm going to select edit, and I'm going to enter into L1 the time and into L2 the wages earned. So L1 is going to be our independent variable, and L2 is going to be our dependent variable. So in L1 I'm going to enter 1, then 3, then 6. And then in L2 I'm going to enter $8.50, $25.50, and $51. Now that the data is in the calculator, we're going to actually do the linear regression that helps us find the equation of the line of best fit. So we're going to hit the stat button again. This time we're going to go over to calculate, and we're going to go down to option 4. Option 4 is a linear regression, and notice afterwards it says ax plus b, just like the form mx plus b for an equation of a line. We're going to hit enter. Now, the first thing it says is that the x list is L1, and that's exactly what we want. Remember, our time, our x, is L1. And then it says the y list is L2, and again, that's exactly what we want because we put the y values in L2. Now, we're going to go down to calculate, and we're going to hit enter. What the graphing calculator does is it calculates the equation of that line that we sketched on the graph. So we have the general form y equals ax plus b, and it tells us that the a value is 8.5 and the b is 0. So all we have to do is substitute those values into the equation. We're just going to clean up that equation a little bit and say that that's y equals 8.5x. So y equals 8.5x is the exact equation for the line that we sketched on our scatter plot. Now, yesterday we also talked about what kind of correlation those data points have, and we said that that was a positive correlation because both variables are increasing. What we want to do is get a more exact value for that correlation. That's called the correlation coefficient. The correlation coefficient tells us exactly how well that line, the linear regression, the equation of that line, fits all the data points. So, back to our calculator. Now, in order for us to see the correlation coefficient, what we have to do is turn the diagnostics of the calculator on. The way that we're going to do that is going into the catalog. So second 0 for your catalog. And we're going to go down to D for diagnostics. So I've highlighted diagnostics on. I'm going to hit enter. And I'm going to hit enter one more time to turn the diagnostics on. And these steps, again, are in the beginning of your notes. You don't have to remember how to do them. What I want you to do is look back on the notes if you forget how. You only have to turn the diagnostics on one time. Once they're on for good. Now, what we need to do is we need to find the correlation coefficient. We find the correlation coefficient the exact same way we do a linear regression. So we're going to go over to Stat, Calculate, down to number 4, which is our linear regression. We already have our list set up. So we're going to go to Calculate and hit Enter. This time when we do the linear regression, we see the R squared and R values appear. We're going to use the R value for our correlation coefficient. And if you notice, the R value is 1. Now, correlation coefficients are values anywhere between +1 and -1. The closer they are to positive or -1, the stronger the regression is, meaning that the data points are very, very close to that line. If R was close to 0, that means that the line really doesn't fit the data points, or our correlation is basically nothing. Because the 1 is a positive number, that tells us we have a positive correlation. So this is a strong positive correlation. Strong because it's close to 1, it's exactly 1, and positive because the value of 1 is a positive number. That tells us, that value of R tells us that this equation, 8.5x, is the exact equation for the data values that I entered in. Now, we use the line of best fit, or the linear regression, so that we can predict values in the future, or possibly values in between some of the ones that we were given in the table. So now what we're going to do is we're going to use our line of best fit to estimate the wages earned when 10 hours of work is done. Now, it tells me that wages earned, remember, is Y, and 10 hours of work was our X. So we use the linear regression, y equals 8.5x. We want to know what the wages earned was, which is our y, when we work for 10 hours, so we're going to substitute 10 in for x. And we're just going to multiply 8.5 times 10, and we're going to get $85. So we can use the linear regression to help us find values that either aren't in the table or are far out in the future to help us predict. Okay, let's take a look at the second example. We're going to do the same thing for the second example. Again, this was the example that we had yesterday in the notes. We've already created the scatter plot. Now we're going to find the equation of the line of best fit. And we're going to do a linear regression for that. And I want you to round all your values to the nearest hundredth. After that, we're going to find the correlation coefficient, talk about what it means, and then we'll predict some values in the future. Now, before we start that, what I want you to do is sketch in an appropriate line of best fit for this data. In other words, if you had to draw a line that would be very, very close to all these data points, what would it look like? And my line might be something like that. Okay, again, that's just a sketch of the line of best fit. We use the graphing calculator to get the exact line of best fit. So we're going to go back to our calculator. We have to enter in the data values into L1 and L2. So I'm going to hit Stat. And again, I'm going to edit the lists. Once you have data in your list, you have to clear them out. So we're going to go up to L2 and hit Clear. And clear out the list for L1. Now, our independent variable was dollars spent, so that's going to be our L1. Our dependent variable was gallons bought, so that's going to be our L2. So in L1, we're going to enter dollars spent. And in L2, we're going to enter the gallons bought. Once you have your data in the table, we're going to hit the Stat button again. This time we're going to go over to Calculate, and we're going to calculate the linear regression. We're using L1 and L2 for our variables, so we're going to go down to Calculate. And this time, notice that our R value is already there, because again, once I turn the diagnostics on, I don't have to do it again. So we have the general form of a linear regression, AX plus B. This time it tells us that A is 0.24, because remember we're rounding our values to the nearest hundredth. And our B is 0.12. Now the graphing calculator also tells us that our correlation coefficient is 0.997. And that value is very, very close to a positive 1, which means we have a positive, strong correlation. Our R value is positive, indicating that as the independent variable increases, so does the dependent variable. And strong because our R value is very close to 1. Now we're going to use the equation of the line of best fit to estimate the number of gallons bought when $15 was spent. So remember that the number of gallons bought was our Y value, and $15 was spent, and that's our X value. Now remember, in the line of best fit, we had Y equals 0.24x plus 0.12. If we're looking for the number of gallons bought, we're going to substitute $15 in for X and solve for Y. So I'm going to give you 1 minute to throw that inside your graphing calculator. And you should end up with 3.72. So when you spend $15, you're going to get about 3.72 gallons of gas. Okay, one last example. We're going to find the equation of the line of best fit for the average maximum daily temperatures in January for the northern latitudes. I want you to round all the values to the nearest tenth and then talk about the correlation coefficient. Now before we do that, we're going to sketch in a line of best fit. And again, we're going to sketch a line that best fits these data points. And notice that our data values are going downhill, so our correlation should be negative. What I'm going to do is press pause. When I come back, I'm going to have the line of best fit already done. So I want you to take this opportunity and you calculate the line of best fit and tell me what the correlation coefficient is. Okay, by now you should have calculated your linear regression. When you do that and you round all your values to the nearest tenth, you should get y equals negative 2.5x plus 137.6. The R value that you get for this linear regression is negative 0.98. Now we use that correlation coefficient, the R value, to tell us what kind of correlation we have. Because the R value is negative, that means we have a negative correlation. And the R value is close to -1, so it's a strong correlation. Now again, if our data values were scattered all over the graph and there didn't seem to be a relationship, that R value would be very, very close to 0. Okay, now we're going to predict the average maximum temperature in January at a latitude of 50 degrees north. Now, maximum temperature, remember, is our y variable, and the latitude of 50 degrees would be our x value. So we use our linear regression, y equals negative 2.5x plus 137.6. We're looking for the maximum temperature, which is y, and we're given the latitude of 50, which is x. So we substitute 50 in for x. I'll give you a minute to find that value. And you should get 12.6. So the average maximum temperature in January is about 12.6 degrees at a latitude of 50 degrees north. Now, for homework tonight, I want you to take the scatter plots that you created yesterday. I want you to draw in the line of best fit. So that's your sketch. I just want you to sketch in a line of best fit on those scatter plots. After you sketch it in, I want you to do a linear regression for each scatter plot. Then I want you to find the correlation coefficient, and not only that, I want you to tell me what that correlation coefficient means. Now, we only had 3 scatter plots for homework yesterday, so in addition to that, I want you to create a Wordle of all the new vocabulary you've learned in the last 2 days. We've done a lot of new terms in the last 2 days for scatter plots, so I want you to create a Wordle of all the new words that you can think of that we talked about for the last 2 days. Now, since we have to do linear regressions on the graphing calculator, if you don't have access to a graphing calculator at home, you can go to this site here, and I've provided a link for you, and you'll be able to enter in the data values for the first list and the second list, and you will see the scatter plot and the linear regression being done automatically.